Kia ora Year 13. If you're in my calculus class in 2016 and you're watching this video in May, then we're not up to this topic yet. I'm doing this video early. You're welcome to watch and get ahead of the class, but you don't need to worry about this for a while. So I will talk in class about where complex numbers came from and some of the history of how they got developed, because it's a really fascinating part of maths. But this video, as usual, is going to focus on the mechanics. So the big thing in complex numbers that you probably already know is I, the letter I, right? So we define I such that I squared is equal to -1. And once you've got that property into your head, it takes us a long way. In all other ways, the number I works like other numbers. So if I've got 3i times 4i, that's going to be 3 times 4 times I, which is 12 times I squared, which is just equal to 12 times -1 or -12, right? Because this property here of I squared equaling -1. There are lots of lovely links of geometry to complex numbers, and we're going to spend a lot of time on those in class and in other videos, but I'm deliberately not going to put those into this first one. So once we've got I squared defined, we can write a new kind of number, z, which is a complex number. And so an example of a complex number is 3 plus 5i. So you can see that when we write it in this form, it's got two bits. This is the real part, and we call this the imaginary part. Right, now there's another form of writing that same number. Okay, but we're just going to start with this version. So we call this the real imaginary form of complex numbers. What I'm going to do now is show you how the first three basic operations of addition, subtraction and multiplication work with complex numbers. Okay, so we'll do that on the next slide. Right, so we'll make up three complex numbers. So Z1 is going to be 5 plus 2i. Z2 is equal to 7 plus 3i. And Z3 is going to be -3 minus 4i. Right, so I've just made those up any old numbers. Okay, now we're going to practice the following examples. So number 1, we're going to do Z1 plus Z2. Number 2, Z2 plus Z3. Number 3, Z3 plus Z1. So 3, whoops, not Zi, Z1. Number 4, we'll do some subtraction, Z2, take away Z1, and then I'm going to do 2 multiplication 1, Z1 times Z2, and number 6, we'll do Z2 times Z3. So you could pause the video now and just have a go at doing those on your own, and just think about, you keep the real part separate from the imaginary part, but when you get to an I squared, you remember that I squared is -1. So have a try and see how you get on with those. Okay, so Z1 plus Z2 is equal to 5 plus 2i plus 7 plus 3i. So all we do is we put the real parts together and we get 12, and we put the I parts together and we get plus 5i. But it's just like collecting up like terms, only we're doing it with numbers. Right, number 2, Z2 plus Z3 is equal to 5 plus 2i plus -3 minus 4i. Oh, that's the wrong numbers. Sorry, that's Z1. Let's fix that up. Sorry about that, guys. Okay, so Z2 was not 5 plus 2i, it was 7 plus 3i. That's better. Okay, so we've got 7 take away 3 is 4, and I've got 3i minus 4i is -i. Right, number 3, Z3 plus z1 equals negative 3 minus 4i plus 5 plus 2i. So this is negative 3 plus 5, so that's 2, and then minus 4i here, plus 2i. So you can see I'm just putting together the real bits and the imaginary bits. So that's addition. Now, in addition, we'll usually have that pattern. Subtraction is similar. I can squeeze this one in here, z2 minus z1. Right? Good idea to put your brackets down when you start these. So 7 plus 3i minus 5 plus 2i. It's just like being back in year 9 when you learnt how to do basic algebra subtraction. Right? So 7 minus 5 is 2. And then I've got plus 3i minus 2i. So that will give me plus I. In the next video we'll get to how we can represent these geometrically using an Argand diagram, but not today. Okay, for now it's just the mechanics of how we do the adding and the subtracting. Okay, now I'm going to look at the two multiplication ones. So number 5 is z1, z2. So z1 was 5 plus 2i, and z2 is 7 plus 3i. Now, even though we've got numbers, the process that this feels very, very similar to is expanding quadratics. Right? So again, think back to when you first learned how to do that. Well, we'll go 5 sevens. So that's 35 plus 14i. Now, plus 15i, 5 times 3i, plus 2i times 3i. So here comes the cool, slightly weird bit, 6i squared. Now we look at how we can simplify that. At first glance, you're going to see that you can go 35 plus 29i plus 6i squared. Right? But we're not done yet because I squared is negative 1. So that's really 35 plus 29i plus 6 times negative 1. Right, which is 29 plus 29i. So when you're expanding or multiplying two complex numbers together, your last term is always going to have an I squared in it. So you're going to have this going on here. So you won't be writing this line out for long, okay, but you probably want to start with. We're going to do one more. If you haven't already done it, try doing Z2, Z3 using the working that I've shown above. I'll do it on the next slide. Okay, so Z2, Z3 is equal to 7 plus 3i times negative 3 minus 4i. So that's a slightly yuckier one. Okay, so we get this times this, negative 21 minus 9i. What do I do now? Let's have a look. Oh, so I've done that one and that one, that one and that one. Now we're going to do plus negative 28i, oh, really just minus 28i. Okay, and lastly we'll have minus 12i squared. So we get negative 21 minus 37i. Right, I squared is negative 1, so this last term becomes plus 12. So that works out to be negative 9 minus 37i. Okay, I'll just put in one more multiplication for you to try. Let's multiply Z1 times Z3. So that would be 5 plus 2i times negative 3 minus 4i. Right, so have a go at that one now. And here comes the answer. So negative 15 minus 6i, right, minus 20i minus 8i squared, which is negative 15 minus 26i plus 8, which gives us negative 7 minus 26i. Right, I just want to check that back because it's really easy to make mistakes with these when you're first starting. So let's have another look at how that one went. So 5 times negative 3 got me negative 15, minus 6i, minus 20i, minus 8i squared. Right, and in here I'm collecting up those two terms to get that one, and I'm saying that I squared is negative 1, so it's minus 8 times negative 1, which gives me the plus 8. Finally, I'm collecting up the negative 15 and the 8, so I get minus 7 minus 26i. Thanks for watching. Make sure you do lots of practice in both the Delta and the New Lake on these basic questions.